Hey there, it's me again. Larry who? Uncle Pleasant. Hey, we're going to finally get around to this hydrometer bit. I think my neighbor is finally done playing with his power equipment. You know, there's some people in this world I don't even trust with a glow stick on the 4th of July. And this moron over here is playing with power equipment. He's a day drinker. I saw him take out his own fence once at 10 a.m. Anywho, I'm going to go over this and hopefully clear up some misconceptions about things. One of the biggest issues that I have is explaining to people that not everything can be detected electronically, which lends itself to the whole there's no such thing as automated cuts with an automated still. You can't just put a sensor in your distillate and tell what's in there as far as flavor compounds go. It just doesn't work that way. And the same thing applies to a digital hydrometer when it comes to ethanol content in water. It's not conductive. You can take distilled water and put the 2 leads of an ohm meter in there and you'll get no resistance whatsoever. And the same thing applies to distillate. It's not conductive. So you have to do things a different way in order to tell how much ethanol is in your distillate. So, keeping that in mind, every time you see one of those movies where there's an airplane flying through a thunderstorm and water gets in and sparks go everywhere, it isn't the water that did that. Obviously something else did, because rain is distilled water. It evaporated, it's in the clouds, it's distilled water, so there's no minerals in it, therefore it's not conductive. Be careful what you buy into on TV. Anyway, as you can see, I have this in test mode again. Still doing serial debugging. But as I explained before, the way this works is that it uses a reference weight suspended from a load cell in your distillate. I can't show you the cup because, well, I guess I can show you the cup, but that's what it looks like now. I didn't know this before, but you cannot put ethanol in acrylic. This thing lasted for quite a few runs, and then one day I noticed there were cracks in it, and then as the run was going, my hydrometer was dripping. Going, oh, well, that's nice. So I ordered another one for this video and tried another run, and I'll be damned. It completely shattered within just a few seconds of the ethanol hitting it. I heard it click and then the little pieces fell. What the hell? So that's all I can determine, is that ethanol and acrylic do not go hand in hand. So I got to come up with another plan. I'm probably going to have to learn how to work with copper pipe and silver solder and a torch and do it that way. But the way this works, it's not like George Duncan's original talking hydrometer, because his used a sonar type of circuit. Not really sonar, but it works on the same principle, where a signal was sent down to a reflector sitting on the top of the hydrometer in the parrot, and the amount of time it took for that signal to reflect back up, it could tell what the hydrometer was reading. It's not a good design, because there are so many ways that you could have that incorrectly calibrated and not have it telling you the correct proof. I also saw another variation on that, where someone took a hydrometer and attached a rod to it with a ferrite bead at the top, and it went up and down inside of a coil of wire, which, that is just as accurate as George's method using the sonar. But still, once again, you're dealing with something that has to be precisely positioned every time you go to use it. So I didn't want to do that. So I looked around, and I showed you in that previous video, where I used that introductory video, where I used an ethanol sensor from that's normally found on a car. And like I said, it works, but if you get air in here, then this thing will throw erroneous readings left and right, and you have to shake your hydrometer to get all the air out of it. Well, that's just about as useless as one that has to be precisely positioned every time. So this went out the door. However, the source code for this is still on GitHub. In case somebody wants to make one, I'll leave the source code up there. But this one, I'll post a video here in just a few seconds, uses an old method that Galileo came up with. Now, Galileo wasn't just an astronomer, he was a physicist, and he discovered that when you are in water, you weigh less because you're more buoyant. The water is lifting you up. And the same thing happens to this little stainless steel ball right here. This is a 64-gram stainless steel ball. When that is in your distillate coming out of your still, it can change weight according to what this load cell up here at the top detects. In straight water, now even though it's 64 grams, in straight distilled water, that thing weighs 56 grams. That's how much weight it loses by being suspended in water. For every 1% of alcohol in your distillate, it also changes the weight of that by 4/100ths of a gram. So it's just a matter of calculating it. Zero proof, absolute zero proof. The load cell will read 56 grams if it's 100 proof, if you could actually do that. It still won't read 64 grams because ethanol still has a certain level of, the density of the ethanol will lift that ball up. So it won't be 64 grams, but it will bring it up closer to 64 grams. But let me grab a video that I snagged off of Wikipedia. It's a scientist in Russian demonstrating Galileo's principle, where this guy uses a wax ball with a lead weight in it. And he puts water in a beaker, and the ball floats, but then as soon as he starts adding ethanol to it, the ball starts falling down into the beaker below the surface of the water. Let's take a quick peek at that real fast. Okay, as you can see by that video, it demonstrates exactly what I'm saying here. In water, that ball was more buoyant. It hovered right at the top of the water level. The more he added ethanol to it, the liquid that it was suspended in became less dense, so the ball would actually fall. And the same thing applies to this. This is how the digital hydrometer reads your ethanol content. Like I said, for every 1% of alcohol, it changes the buoyancy of this 64-gram reference weight by 4/100ths of a gram. I'll do a quick little demonstration here. I'll use my phone to drive instead of the iPad up there, which is not really in view. I'm gonna send a command to the hydrometer to reboot it. Let's see, hydrometer, Reboot hydrometer. That should talk.
Sending the command to reboot the hydrometer.
Okay. As you saw, the screen went white. Now it's restarting. Tells me to remove the reference weight, and it's pausing 15 seconds for me to do that, which I already did. And then this will change again. This whole startup process takes 30 seconds, so I'm going to waste a lot of video time here. And now it says attach the reference weight. I'm going to hang it on the little wire hook in there. And it's waiting 15 seconds again. And after that 15 seconds, here we go, it's looking at that. Says the load cell's calibrated. Right now it's giving me 30 seconds to put my parrot cup back in here, which would, yikes, hard to do this one-handed. Well, here, let me ditch that phone. There, one-handed, did it. Huh. So you just put that in there and then you're off to the races. After it starts going, you know, your run begins. As soon as your boiler's up to temperature, it opens your valves up there. Then it also sends a command once again to recalibrate the load cell. There we go. But since this cup is destroyed, I said I got to come up with another plan here. It'll have to be something made out of copper pipe. I have never messed with copper pipe, so not sure if I trust myself with a torch. I tend to injure myself quite a bit. But other than that, there is a temperature sensor back here hanging behind the reference weight. What that does is it reads the temperature of your distillate. If it's over 75 degrees Fahrenheit, can't remember what that is in Celsius, 23, 24, something like that, you're running the risk of getting your house filled up with ethanol vapors, and you can make things go boom. So what that will do is bump up the water flow on the condenser valve to cool off your distillate even more. That seems to be a problem with the T500s. People like to run their condensers really slow because of what they were taught out of the manual, and you'll end up with hot distillate, and that's the last thing you want near an open flame is a bunch of ethanol vapors. And then the line from the condenser connects here. There is a flow sensor. I'm going to have to redesign this just a bit because it uses an optical detector to tell when there's drops coming through, and it doesn't catch them every time because, well, obviously ethanol or your distillate's clear, so it doesn't interrupt that beam, or usually doesn't distort it enough to actually trigger this. And the reason that's on there is because if you want to tell your still controller to shut down the run once you're only seeing about 50% of your output from your still, you can shut it off right there. But that's about it for the hydrometer. I just figured I would cover this and show that video of that Russian scientist showing how Galileo's principle worked for detecting basically liquid density. That's how Galileo first showed people how to tell the density of a liquid. You hang something in it, and depending on the weight change of the item hanging in the liquid, that's how they could calculate liquid density. So I'm going to wrap up this video. Hey, what do you know? This one didn't last half an hour. And eventually we'll get to another video where I go through the build on one of these. I'm still not sure what I'm going to do here with these because when it comes to selling parts, so people don't have to do any soldering, About the only way I could do it is just to sell a complete hydrometer, and I don't want to do that because that puts me in that risk category again, where somebody can blow it up and say it was DOA, and then I'll end up having to refund their money and get a blown up device back. So I still have to figure out how I'm going to do that, unless I just very clearly state no refunds, because I'll test it and make sure it works here before I send it out. But like I said, just the way people are these days, they'll screw something up and then go, oh, I'll just say it was dead on arrival and I'll send it back and get my money back, or get another one. And now I'm out the original purchase and I'm stuck with a dead unit. I don't want to do that. So anywho, that's all for this video. We'll catch you around next time. Have a good one. Bye.